walkthrough of the translation pipeline. Now, the goal here, based off of my understanding, was to take a source language CSV, translate that into 50 languages, and then output a new CSV, and we'll do that with one column per language. Now, in this case, I just made a static input to test the code, and this pretty much only has the requirement being that this is a source text column, and everything else here are the text that would be put into the input stream. I do want to mention that I've started building the server over here already, because this usually takes maybe 2 to 3 minutes. But yeah, so I started that on local, set up this NLLB server so that I can test the code. But yeah, so let's go over our config file. So this file, as you can see, defines the target languages. You can see all 50 in this case. And what it does is it maps output column names to language codes. So that way you can scale to 100 languages without really changing any code at all. At a high level, the system is split into two pieces. We have the Rust side owning the orchestration. So this would involve reading the CSV, batching rows, and handling retries and concurrency. And also, of course, writing the output CSV. Now the actual translation lives behind an HTTP boundary as a provider. And right now that provider is NLLB, running as a local REST service. But the Rust pipeline doesn't depend on LLB specifically. But yeah, so for performance, rows were initially, when I tested them, just one at a time. So that meant a bunch of requests. But I've decided to do some batch scheduling, and that dramatically reduced the number of requests and improved the throughput for larger files. When the server is being built, you can actually run the command into our translator, but let's see, it's okay, perfect. It should run in maybe like 10 or so seconds, but in the meanwhile, we can go over the our Rust CLI. So over here, this would read the input CSV. In this case, like for example, book a ride or your driver has arrived, and then it would translate that phrase into each target languages. And now we wanted a large number of languages, say 50 plus. And as you can see here in our output, after a successful run, it translated book a ride into 50 languages, which is a huge win. And yeah, so input stream, output stream. Do want to note that as it runs, it batches rows per request, which avoids making one HTTP call per row, as mentioned earlier. And perfect. Okay, so this finished running, and that means we can test our command, and then we can see it working right now. So as we wait for the code, we can see the requests are successfully being made, and the user flow is pretty simple. The inputs are then put into the job. The job is being run, and then our output is the CSV file. The pipeline is provider agnostic, so adding another backend like Gemini, which we didn't implement in the code here, we just tested with our NLLB server, but that would just be implementing the same provider interface. And let's just wait for this to finish running, and then we can see the output. Perfect. All right. There we go. Thank you very much.